Okay, so you guys have to deal with that things. And as I said, there's there's an endless amount of practice that you can do. Uh, but as long as your fundamental idea is very clear, your rules are very clear, you are in a strong position. That much I can tell you. Okay. Anybody has any say, any comments before I leave completely the inequalities portion? Anybody has a feeling, sir, we still didn't have that quite a good practice in inequalities? I don't think so. We have done quite a lot of practices.
A lot of inequalities.
Have we done enough? Yes.
Yeah, I think.
I feel like
Yeah, because we have
Also-
also done like absolute value inequalities. So
Yes.
yeah.
Yes.
Also, a quick question. Last class, you said that if we wanted some more practice problems, you could post some more on Flexi quiz.
Yes. Yes. Of course.
Could you post a few more, please?
Yes. Yes. Of course. Somebody wants more problems related to inequalities. I can definitely assign. Okay. More worksheets. In fact, we have multiple worksheets for different topics. So anybody who's interested, I don't have any issues. Okay. But it depends on like how much you would be able to do. That's the main idea. Okay, can somebody remind me what was the inequalities worksheet did I assign earlier? Inequalities basic, inequalities part 1. What was that? Anybody remembers that? Okay, let me assign inequalities basics. That would be
it was inequality expression part 2 and inequalities graph solutions part 4.
Okay, so I'm assigning this to math group Monday, Wednesday, Friday. Okay, that should come now in your account. Okay, then I'm going to do inequalities. Let me see if I have good inequalities. Okay, let me inequalities graph solutions part 4. Okay, I have already signed inequalities expressions part 1. Okay, I am assigning this part 1, but the questions aren't very easy. So please, I would say that don't get into like, no, I need to definitely solve all of these, but pick your best ones and just practice from there. If you're not able to bring it in the class, we will discuss. I've assigned 2 additional worksheets to the entire group. They can very well refresh their page and it should come. Okay. Okay, if you do not have any concerns, I would like to start and move on to a new topic. And I think we are going to start. See, these are all covered. I think we should start getting for functions and graphs. Functions and graphs is a topic which I would say I don't see any SAT question paper where functions and graphs has not been asked. So that is an area where we have to be rock solid. Okay, functions and graphs. Anybody has any concerns before I start that?
No.
Anybody who's excited to know about functions and graphs?
Fine.
Yeah, me too.
Okay.
I'm interested.
Okay. Others are kind of silent. Okay, how many of you already know about functions and graphs?
Yeah, I know.
Kind of know like the basics and everything.
I know about it.
Yeah, I know the
I
basics.
know a little.
I know a little bit.
Others are still quiet.
I
As
know
we-
a little bit, but I heard that at SAT they phrase the problem very differently.
Okay. I will make I'll try to make functions and graphs as your favorite topic. because I am going to actually get the inside the the crux of that topic. So don't worry, leave it on me. You just follow me properly. You don't follow, you raise your questions. That's very important. Others doesn't seems to be so excited about functions graphs.
I'm pretty excited. I'm not too strong in like function notation equations, so
I can tell you very much that you will enjoy learning functions and graphs. It's the most, I would say, a very, very interesting topic. If you understand it properly, you will enjoy solving functions and graphs. Okay. Now, as I tell you guys, your algebra, your exponents and radicals, those are such basic things. If you don't, if you're not very kind of champ on those areas, functions and graphs and all those topics will include it. For example, if I say fx is equals to tan theta, okay, you don't know anything about trigonometry, that will become a roadblock. So that is why I covered trigonometry first, exponents first. Have we covered exponents and radicals, guys? I think we covered, right? Or no?
yes, we have.
At the very beginning.
Okay. We covered the exponents and radicals, right? Anybody who says that we are not covered it, maybe you are not there in the class, or you are we sure 100%? Okay, I'm assuming that I've covered it. Okay. Okay. Let's get started. So whoever said, sir, I know a little bit. There are two words that we have to understand very, very clearly. Something is called a relation. Okay. And something is called a function. Relation and function. Okay. It becomes two different things, basically. There are two different things. If I say y equals to 2x cube plus 9x square plus 17. Okay. Is that an equation?
Yes.
Yes.
It is not an inequality, right?
No, it's
No.
not.
It's an equation. Okay, fine. Got it. Okay. Let's ask ourselves. This equation is establishing some kind of relation between x and y. Is it or not?
Yes.
Some kind of relation, right?
Yeah.
What kind of relation it is? A fixed relation, right? What is that kind of relation? How can you say that it's a relation? Yes. If x is equals to 0, y equals to 17, definitely, right?
Yeah.
Yes.
So both are tied together, is it not?
Mm-hmm.
Yeah.
Y is not independent and x is also not independent. Am I okay?
Yeah.
Yes.
Why is x not independent? Because if I put y equals to something like 0, then x will have to take some value, right? Something has to come for x also, right?
Yeah.
Is it not? So
Yeah.
they are both tied together. Somehow they are tied together. They're not independent. So it is a relation. Okay. Are we clear?
Yeah.
Now the problem
Yeah.
is, after this thing comes function. So the most important thing we have to understand is what is the difference between a relation and a function. I will give you few minutes because that's the most starting point of this entire topic. So I will let someone to explain me what is the difference between a relation and a function first. Silence. What happened? That I kind of know it. Try it out. Not asking you to be 100% right here.
I think I know.
Okay, you know, go ahead, please.
So I think a relation can have like many outputs for a single input, but then for a function, it only a single input can only have one single output.
Are you sure that's the definition?
I think that's what came to my mind.
Okay, I will take that as input. Thank you. Others, please.
जवाब देना पड़ रहे हो ना.
Somebody, I heard some background noise. Somebody's.
Oh, sorry.
Yes. We are still on functions and relation. Anybody who wants to explain that? Okay, just try it out. Do some guess at least. That, sir, whatever I've studied in the past, based on that, this should be the case. No? Silence. Okay, I will explain this. The topic starts with understanding the difference between a relation and a function. Okay. This topic altogether, the functions starts with some sort of understanding. Okay. Simple understanding is, okay, we will have to learn this from different angles actually. Okay. Now, there is something called vertical line test. Anybody heard about it?
Yes.
Yeah,
I
I've heard.
Yeah, it's basic.
Yes, I have.
Okay. Anybody who wants to explain vertical line test?
So if you plot a vertical line on like an x point, or two, there should only be one point touching the vertical line. If there's more, it's not an equation.
Okay. Now, whatever you guys are giving me is kind of half-baked. Half-baked. Let's completely bake it so that the, your snacks is perfectly crispy and solid. Okay, so let's see. Vertical line test is about understanding whether a graph or any relation is a function or not. See, when you write something in terms of x and y, it is already a relation. So whether that relation is a function or not is something we have to identify. Anything that you equate x, y, m, n, h, x, k, l, whatever, those are already having a relation because there is an equals to, they are tied together. We have to understand how can we identify that those are functions or not. That is what we are going to do. Okay, fine. Now, to make a relation a function, there are certain criteria. First, we have to understand vertical line test. Vertical line test speaks about graph number A. Okay, like this. This is x and y axis, x positive, y positive. And it says, I am a straight line. Number B. It says, same coordinate axes, and it says, I am a circle. Okay. Number C. It says, I am a parabola. Okay. Number D. It says, I am a parabola, but a different parabola. Like this. Number E says that, sir, I am looking like an exponential graph. Exponential graph. Like this. Exponential graph like this. Okay. F says, I look like something like this. Okay. Now, what vertical line test says is, if by dropping vertical lines, if that graph intersects only and only at one particular point, then it's a function. Otherwise, it is not a function. I repeat, if you are dropping vertical lines, okay, in the sky, and those sky generated vertical lines intersect the graph at only one point, then it is technically can be represented as a function. So let's start doing so. Okay, so I will say I am dropping the line. These are vertical lines. Okay, and if I do like this, okay, I have intersection point these. Okay, now I do like this. Okay, for the same vertical line, I have 2 points of intersection. For the same vertical line, I have 2 points of intersection. So this is not a function. It cannot be represented as function. But since in this particular graph means a straight line is also a graph. When the vertical line test was done, the point of intersection is just one. For every single vertical line, there should be one point of intersection. Then it's a function. So if this relation is, let's say, y equals to 2x minus 5, then y can technically be written as something called f of x equals to 2x minus 5. In this particular circle equation, which is x square plus y square equals to, let's say, 4, f of x cannot be written. Am I clear?
Yeah.
You can write y equals to fx for a relation. This is a relation. You can represent this relation as a function only when this graph, which is y equals to 2x minus 5, passes through the vertical line test. Am I clear? Yes. Some yes, no.
Yeah.
Yes.
Graph C is a function or not?
It's not.
A function.
It's not a function.
It's a function.
It's not
Wait,
a function.
it's not a function.
Not a
Not a
function.
function.
Yeah, it's not a function.
Why it is not a function?
It
Doesn't
like
pass the vertical line
it
test.
intersects the vertical line 2 times.
Are we clear? It is not a function. Are we sure? It's not a function.
Yes.
Sure.
Yes.
Yes.
Yes, it is not a function. Is this a function?
Yes.
Yes.
Is this a function?
Yes.
Are you sure?
Yeah, that is function.
Some doubt I can sense. Is that a function? Please ask yourself clearly and tell me the answer. Is that a function or no function? E is a function or not function?
It's a function.
Function.
It has not been like 100% like an exponential graph, but exponential graph goes like very steep. Okay, and I assume that when you draw a vertical line test, I don't think there will be one coordinate point where it will have like a vertical line that can cross it. Are you getting my point?
Yeah.
Probably like it's not that case. Is that fair enough? Let's assume that this is the case. Okay, so this is the function. What about f?
It's not a function.
It is not a function. Are we clear? So do we understand the difference now? Yes or no?
Yes.
Yeah.
Okay.
Yes.
We understand the difference. Okay. Now look at this question at the board. Okay. I don't have to tell you, you can answer that.
4.
4.
It's 4.
Or
Are we all clear? What is not a function and what is a function now?
Yes.
Very, very
Yeah.
clear. Anybody has
Yes.
any doubts? Anybody has any doubts? Okay.
So is it like a function cannot like have the same y and like the same y in like different y's but the same x?
Different y's and same x. Okay. So Ayush, I will come to that point. You will understand it right away.
Okay.
Coming to that point. Anybody has any queries till now on the vertical line test and understanding from a graph perspective? Please note, we just learned how to identify a function when the graph is in front of you. And we understood what is vertical line test. Only about graph. I have not gone ahead. Now I am going to come to values. Are we clear? Am I clear?
Yes.
Yeah.
Fine. Anybody wants to take a snapshot, please go ahead. I'm going to clean up the board, please. Okay. Now, there is another understanding to this entire theory. Okay. If I don't give you, what was that?
So are we supposed to memorize the equation for the circle?
No, not right now.
No,
But
okay.
the thing is, circle is included. Circle coordinate part of the circle is included in your SAT.
Yeah.
So you have to know about the circle equation.
Okay.
Okay.
Just one more
Now,
quick thing. It's kind of
yes.
unrelated, but so I know we have to know the circle equation, but you know, like the other types of graphs you showed, do we need to know any of those other formulas, like the sideways parabola?
You understood the vertical line test?
Yeah.
That's all.
Okay.
Understand the important things first. That's the key factor. Okay. Now we are coming to the values. How to identify if something that is represented, a relation that is represented in terms of values. Why I'm calling out as values? Because what we have just learned is how to identify if something is a function based on graph, right? Based on graph and vertical line test. I do not have a graph now. I just have values. And there are two systems, X and Y system. Okay. And I have to tell you whether it's a function or not. Okay. Only values, guys. No equation is given, no graph is given, only values. How do you identify that? So in books, you will find this very interesting ellipses being made. This is A, this is B, or you can also say this is X, this is Y. Okay. Now there will be some values, -1, 2, 0, 4, 5, -2. And correspondingly, there will be 2, 6, 9, 3, 4, 5. These values being given. I don't have an equation. I don't have a graph. Here is the key point. Another one. X and Y. -1, 0, -2, 2, +1, 6. Okay. This goes down to, let's say, 2, 5, 6, 9, -1, -2, 5. Let's say. Okay. So we have got these two models right away. Okay. Let's take another third model. This is again X. This is Y. Okay. So we got another third model also. What is happening in the third model? In the third model, what I'm going to do is same. Let's take some random sample value. -1, 0, -2, 6, 5, and let's say 0. And then I will say -5, 2, 1, 9. And let's say this, let's say -7 and 6. Okay, now the values is becoming complicated. Now we have to identify from the value that what can represent a function and what cannot represent. Somebody wants to guess and give some idea.
Yeah, I know. Yeah.
Okay,
So-
Sai, I will stop you.
Okay.
Anybody else?
If there, sorry, if there's more than one, if there's multiple x values that are the same, then it means that it's not a function.
Are you
Because that
sure?
basically means that, wait, I think I might have mixed that up. Yeah, but, I think I mixed up the x and y, sorry. So basically
Okay, I'll
for,
come back to you. Go on. People who are quiet. Either you come back forward, otherwise I'll have to call out some names.
I can say something.
Yes, Karthik, go ahead.
Every x value has its own y value. They can be mix and matching. It's got to be like very unique. Simple way to put it.
Okay, so what does it indicate?
Only one y value. Like each x value only has one y value. Like,
Each x value has one y value only as per Karthik. How many of you say that yes, I agree with Karthik?
I agree. I agree.
I also
I
agree.
agree. Yeah.
Yeah, I
agree.
also agree.
Okay.
A y value can have multiple x values.
Now this multiple is very confusing. Are you sure multiple works for functions? Why are
Yeah.
we calling multiple x to multiple y to multiple x? What is happening? I don't know.
it's only if there's multiple y's for x, because then if there's multiple like x's, then it would be the horizontal line test, and that doesn't exist.
Okay, let's make it a little more easier.
Can
Why
I say
don't we
something?
say that it's one to many or many to one as application? One to many or many to one? Which will make it a function? Can you define that?
Can you repeat that?
One
Probably
to
one-
many or many to one?
I think one too many, maybe.
One to many is a function, correct?
Many to
Yeah.
one.
Wait, never mind. Wait, what does one too many mean?
One means you are taking one from here and many from here. Means one is mapped to many from here. Or many from here mapped to one from here.
Yeah, it's many to one.
It's many to one then.
Yeah, it's many.
That indicates that it's a function.
Yeah.
Okay.
Yeah, because then the line could technically just be a straight line, and that counts as a function.
Okay. Are we sure?
Yeah.
Actually,
if it's one to
I think it may be one
I
too
think it is
many.
many to one.
Maybe one too many, because I'm trying to like I'm trying to like imagine, I'm like looking the vertical line test, like if we're doing many to one, that would mean like many x's like would be one y value, and like that would mean like, oh wait, never mind. Wait. So wait, I got confused.
Good. Confusion is good. I like confusions.
Yeah, I think it's
Yes,
many to
anybody
one.
else?
Many to one.
One to many, many to one. Acha, okay. It's somebody else. There is a lot of people who are like very quietly listening. At least say something. At least support your friends. At least come on. I'll have to pick. Who is not? Who's less speaking? Aradhana, did you give some? Jet Harun, I am expecting some voice from you. What happened today? Having audio problems? Anybody having audio problems, guys?
Oh, can you hear me?
Anybody on audio problem, please? Guys, I tell you, I promise you, you tell me that I have audio problems and I will just call your mom or dad and you will get a new, I'm telling you, I've done many times, new audio set. Promise you. Just tell me that I have audio.
Sorry, I was in the bathroom. I just came back and
Did you miss something, Jatharu?
yeah, I heard something about many to one. That's the last thing I heard. But I don't know what
Many
that
to
means.
Yeah.
one? Are you understanding this?
I don't know what
Anybody
that
wants to
means, but
explain?
I understand what's on the board, but I don't know what that means.
Okay. Okay. Somebody wants to explain what we are discussing to Jatharu.
Wait, so okay, I think we're discussing like one to many, which is like 1x to like many y's or many x to one y. And then like we said like many x to one y.
Yeah, many x to one y is a function, but one x to yeah.
1x to many y is not a function?
No, because that would like be
Yeah.
like in 1x, like I got confused before. I kind of missed like swap the x and y, but like in like in one x line there can't be like many y's. It would fail the vertical line test.
Okay. How many of you say, sir, this is confusing? At least you say that one, at least. That's sir, I need to be like a very clear explanation. Anybody who thinks like that.
I'm really lost.
I think it's like, you can understand it, but it's kind of hard to like put it into words. But you can like understand.
Yeah, that's what I was about to say.
Very good. So here is what I would say. Okay, very, very clean and clear. Okay. These are all unique values.
Yes.
For each unique value, there is a unique another value.
Yes.
Yes.
For each unique value of x, there is unique value of y. Right?
Yes.
So if you go back to the concept of vertical line test, if each vertical line test, as we discussed, we drop this, okay? So that means it will intersect only at one point.
Yes.
I mean that concept is coinciding, right? One x value will always have one y value, or one y value will corresponding have only one x value. Right? Can I say that?
Yeah.
More or less. But please note, this numbers and the values theory does not completely match with the vertical line test. Please don't keep that in notion. Not 100%. So when you see one value to one value or one value to one value, vice versa, it is a function. This is a function. Is that clear?
Yes.
Are we clear?
Yes.
That rule is clear. Okay. Now,
Yes.
let's see the magic here. What is happening is, before I actually come to this here, let me come to here. You have two same values.
Yes.
Yes.
Same values, if you put, what is happening on the other end?
They have different y values.
Okay. So in this particular scenario, let's remove this. Okay. Let's remove this and make it like this. Does it become one to many function?
Yes.
Yes.
But wouldn't this not be able to be a function?
It's not a
because-
function.
Yeah, this one.
One to many is technically not a function. Are we clear?
Yeah.
It is not a function. Not a function. Not a function. Okay. Cross. Now let's come back to you. I see that 0 here, okay, is mapped to 5. Okay. And 6 is also mapped to 5. Rest is like 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Let's just omit one of the values. Let's say I take out this one. Let's put 9 here. And this is 6 here. Are we seeing that there are two values, 0 and 6, for which corresponding y value is same?
Yes.
To make the thing simpler, I will clear this one out. And I will straightforward, I will put it like this. What kind of thing it became?
Many
Many
to
to
one.
one.
Many to 1. Okay. I will say this is a function. This is okay. Are we clear?
Yes.
Yes.
So we have done function, this thing. There is last example if you want to take, but that is a nonsense example. I will draw 2. I will say -1, 0. Okay. 0, 2, 5. This becomes 2, 9, 9, and 2, 5 becomes 6, and 6. 1 too many, so 0 to 6, 6. Okay. And 0, 0 becomes 9. 0, 0 becomes 0 becomes. This in this example, you will see that 0 is mapped to 9, 0 is mapped to 5, which means this 0 is making a one-to-many relationship, and you can simply remove this one. And for 2 and 5, this is mapped to the same 6. Okay? You can remove this one. So this is many to many. Am I clear?
Yeah.
Stupid. This is never a function. Are we clear?
Yes.
So now we know what is a function and in the which criteria it is not a function. We are clear.
Yeah.
Now comes a little tricky part. One unknown function we know. Can somebody give me a real algebraic expression? Something with this algebraic expression or graph where this function can be shown. A scenario like this.
Well, we can do the circle equation.
You can do the
Circle does
quadratic
not come as
equation.
a function.
Or for like just each x, we just figure out what the corresponding y is. So like for -1, you just plot a point at
Give
2.
a little stress to your mind.
I'm sorry.
Give a little stress to your mind. The answer will come. Absolutely, the answer will come.
For many to one, you can do quadratic.
Not quite convincing answer. Ask is simple. You have these values, you know many to one is a function, but I want you to prove that it is a function.
Basically, you could just
Give me something which looks like a graph and you prove it that it is a function.
You can graph the points and connect them and then do the vertical line test.
Everybody getting my point?
A parabola?
Wait, so we should tell an equation for like a graph?
You should tell me something which will represent this. You either make a graph. Before you make a graph, you should give me an expression which will depict this.
5x squared plus 6x plus 18 equals to 0.
But will it always land at the same values? That's the problem. No, doubtful. Okay, you all have just completed it. I have given you a hint now. What can be an expression where you give multiple values of x, but the y outcome will be just one?
Wait, can you repeat that?
Where in what scenarios you put same value of x or multiple values of x, but y value will remain same? In what scenarios?
Y equals x, or like y equals x.
Y has to
When you have
remain
a horizontal
same.
line.
Yeah, like y equals.
X values may be different, but y
Y
will
is the same.
become,
Yeah.
y will
make it-
remain same.
You could just make it like x equals 3 or something, and it would always equal
You
3.
have, you can feed multiple x values, but y will remain same.
It's a horizontal line with like
Oh, I
the
meant y
undefined
equals
slope.
You just completed in the past 2 sessions. Multiple x values you can feed into that equation, but y will come out same.
like maybe just y equals like a number, and then it would be a horizontal line, any x.
What is this, guys?
Absolute value.
Oh, absolute value.
Okay.
X is equals to -5. Y is +5. X is equals to +5. Y is still 5. This is where you can have multiple x values which points to the same y value. Now don't go by the fact that, sir, this is 0 and 0 is 6 and you are pointing it to 5 and you are asking me like that. No, I am just giving an example. It could be this is +5 and a -5. They become both a 5. Now to prove that it's still a function, how do you prove that? If you draw the graph of this, okay, the graph becomes like this. Draw it and you can check it. The graph will become like this. And this graph passes the vertical line test. You see, this will pass the vertical line test. How many of you are able to correlate now? That yes, sir, getting it.
Yeah, I can see why.
Yeah, I get it.
I can.
I can.
Who is not clear? Anybody who is not clear? Ikshita, Ishan, Devak,
I'm clear.
I'm
Sarah,
clear.
Shreya,
I'm clear.
Jetharun,
I'm clear.
Sai Purnima.
I'm clear.
Okay, absolutely clear. Okay, okay. Now, is that something that is becoming interesting?
I'm
Yeah.
having a little trouble with my audio. I don't know if you guys can hear me.
Yes, you have some problem with your audio for sure. I'm not able to clearly hear you.
Okay.
Please fix your audio issues, guys. Please, this is my humble request. Please don't get into any audio issues here, please.
I don't know why, because it works on like other stuff. It's just for Zoom that it doesn't work.
Okay, please spend few hours, okay, of your crucial time and get it fixed. Okay, now I'm cleaning up the board. Anybody wants to take a snapshot, please?
Um,
Okay, I will assign this to some names actually. This should be coming from Karthik, Latik, Sai. No, not Sai. It should be coming from Sarah, coming from Shriya. I want all these 4 folks to at least speak here on this problem. It could be, sir, I'm thinking, I'm not sure, whatever. Sir, I got half of it, not 100%. Sir, I will follow what my friend says, whatever.
I know the answer.
Who was that? That was Sarah. Okay. Others, please.
I'm not sure.
Who was that? Latik. Okay.
I'm thinking.
Okay. Shriya, you are thinking. Okay. Where are you stuck? Did you understand the rule I expressed here?
Yeah.
What was that rule? What is the main key component where it will not be a function? What is the main key rule where it will not be called a function? Can I say 1-on-1 is a function? Shriya,
Yeah.
is many-to-one a function?
Yeah.
Is one-to-many a function?
No.
Do you see any one-to-many? Try looking at all the values. Do you see any one value in X which has multiple value for Y? I see a lot. If you took at number 2, when X is equals to 0, there are 2 values, 0 and -1 both. Is it one-to-many?
Yes.
Okay. So it's a function. Number 2 is a function.
No, it's not.
Okay. I was still talking to Shriya. Shriya, are you replying? Shriya.
Oh yeah, I'm here.
Okay. Do you see number 2 as a function?
No.
Are you confused?
No.
Good. Many-to-one can be a function, right?
Yeah.
Many-to-one can be a function.
Yeah.
Okay. Do you see any many-to-one function here? Many-to-one scenario? Who sees a many-to-one scenario here?
I see one.
I see one.
I see
Akash.
one.
Many-to-one scenario, please.
Yeah. Do I just say what I think it is?
Yes.
Okay,
Many-to-one, which one is? Which one?
The many one is the third one.
Third one? Because
Yes.
3 and 7 has both 2 as the value, right?
Yeah.
That's
Then why
one too
is it
many
not a
though.
function?
Wait, no, that's like the answer, what I think it is. Like that's the function.
That's the answer?
Yeah. Number
Hmm,
3.
I would say many to one is number. Wait. Many to. Yeah, many one is number 1. I would say, and I think that's the answer.
Number 1 is the answer.
Yeah, no, I said number 1 is many to one.
Number 3 is not many-to-one.
Many-to-one.
No, that's one too many.
Many-to-one is number 3, and number 1's one too many.
Oh wait, never mind. Wait, so never mind. I got confused. I'm
agree.
sorry.
Okay. So with all these many-to-one, one-to-many, and all this R&D, what is the final call? Which one is the answer?
Number 3.
3.
Number 3.
Number 3.
3.
Okay. Now, honestly, tell me how many of you are clear that number 3 has to be there? It
I'm
satisfies
clear.
the condition of a function.
I'm clear.
Yeah, it does.
Yeah, it does.
Are we all clear that yes, sir, this is a function?
Yeah,
am
I'd say so.
Yeah.
Yeah.
Yeah, this is a function.
So guys, if you are confused by any means, one straight thing you should remember. 1-to-1 is a function. And many-to-one is a function. That's all. Others, I don't know. As soon as I see that there is no violation in 1-to-1 or many-to-1, I see that that is 100% there, then it's a function. Can I say that?
Yes.
Okay. We are clear what is a function, what is not a function, right? Yes, no, no, yes. Yes, sir.
Yes.
Okay. Guys, I am going to take another 5 minutes. We are going to learn something very crucial. Okay. And that's something that is generally not asked in SAT. Okay. But function as such is fully included. And if something is included, you just never know that tomorrow when you are there, the question is being asked. Okay. So we can't, we can't skip that. Okay. Now, what we are going to learn is about odd and even function. And there is a category called neither also. Okay. These are the categories. Odd and even function and neither function. Now that is a very difficult zone basically. Algebraically, it is a little bit as long as your algebra, again, as you can calculate properly, you can identify it. Graphically, it's a little tricky to understand if it is a odd even function. But let's go algebraically first. Okay, algebraic. Even function here, f of x will be equals to f of minus x. Okay. Odd, f of minus x is equals to minus of fx. Neither, when not even and not odd, then it is a neither. Joel says, sir, what is this confusion? It's all, you are making it all confused. Why I should say f of minus x is equals to f of minus x and f is equals to this and that? Why are those coming? Okay. Let me clarify. When you have a relation, then you say that, sir, I have a relation. So that means I can write down y equals to x square minus 4. Relation. I'm talking about relation, not function. So suppose this particular equation is nothing but a function. That means it will pass the vertical line test. But I am not here to judge and test every time that it will passing or not passing. I'm not here to do that. If it is written in the book that it is a function, I will take it as a function. I know how to identify it as a function, but since it is y equals to x square minus 4, and if it is written as fx is equals to x square minus 4, then it's a function notation.
Yes.
Yes.
Now, before writing it, did I ask you, give me a proof why are you writing? Did you do vertical line test? You will say, no, sir, I have not done it. But you still wrote it. Fine, no problem. You wrote it. And that's how we will be continuing. We are writing anything to the function notation, but that doesn't mean that it will become function. But we are writing it. Let's suppose it is a function. Now what I'm going to do is, this is fx. What I'm going to do is, I'm going to see if fx is becoming f of minus x or not. So what I'm going to do is, I'm going to write in this fx, I'm going to write it as minus fx. Now, substitution rule is very, very important. Substitution is not something that you have actually learned in system of equations. This substitution is a little different. Means similar. It is works like similar. Here x has become minus x. It is treated like this. X has become minus x. So the right hand side, whatever it is there, no, that will also become minus x. So I will write it as minus x square minus 4. Is that okay?
Yes.
Yeah.
Minus x square is nothing but x square. Is it true?
Yes.
And this will become a 4 again.
Yes.
Now, if you go back and see, this expression was originally y, and then we also wrote it like as a function, right?
Yeah.
So this can be written back as f(x).
Okay.
Say, I'm confused, sir. Why did you do that? Anybody? Nobody wants to say. I'm confused.
Yeah, I have no question. Wait, never mind.
See what logically I have done. I am saying fx is equals to this. Fine, no problem. Then I am saying that I am replicating, I'm using this equation and substituting minus x in lieu of x. So the rule says if you are substituting anything for x, right hand side x, we also substitute the same thing. So that became minus x. But finally I got x square minus 4. This x square minus 4 looks like an fx. It is the original function. So finally, did you get f of minus x is equals to fx?
Yes.
Yes.
So this is actually an even function. Am I clear?
Yes.
Yes.
I will give you the last example for the odd function, and then that's going to be the end of the class. F of x is equals to 3x cube minus 7x. Now don't ask me, sir, why have you written fx? I have not done any like a vertical line test and all those things to be able to write. I don't know what is the graph of it also. I don't know that. But I have written it in a function notation. But technically function notation means it should be a function. It should pass a vertical line. We are not validating. We are not going back now. We have just written it. That's it. Now let's see what happens if we do a minus x. As I told you, when I substitute a minus x, you have to do the same thing over here also. Am I clear?
Yes.
Yes.
Now this becomes minus of 3x cube plus 7x.
Yes.
Now I will take a minus common. Does it become 3x cube minus 7x?
Yes.
And if you think it properly, this is nothing but the original function minus of fx.
Yeah.
So I proved that in this particular expression, f of minus x is equals to minus of fx. Did I prove it?
Yes.
Then what does it make?
Odd.
Odd function. Okay. As a task, you guys will check whether this is an odd function or an even function. Okay. So I hope the basics of the entire function theory is all clear to everybody. Anybody who felt like, no, this is not such a very easy topic or not an interesting topic. It will go nice. Don't worry. Learn the basics first. It will go very nice. We'll do some very tough and typical problem, which you will enjoy. Okay.
You're gonna find if it's odd, even, or neither on a graph.
You want to have it on the graph? We will come to that later. Don't worry.
Okay. Yeah, because I have like small questions about them.
Yes. Okay. If you have questions, you know my WhatsApp number, you know my email. Okay, you can bring it, ask your questions on here also. Okay, no worries. Okay, thanks guys, thanks for joining. If you do not have any questions, please log off. Please remember these ideas. Please remember this whole basic idea of functions. We'll continue Wednesday same time, where we'll be discussing more about functions and graphs. It's a very interesting topic and it will take some time, maybe 2 to 3 classes. Okay, thank you so much. Bye bye.
Can I take a screenshot?
Yes.
Thank you. Have a great night.
You too.
Thank you. Bye.
Bye bye.
Thank you.
Bye. Have a good day.
You too.
Also, is